I think we are ready to go. You can share screen. We start.
All right. So we're saying that we can.
Yes, we go. We go on.
Get started with a word of prayer and to give us a word of prayer before we. Musimbuzi, can you give us a word of prayer? Musimbuzi Simon.
Okay, let's pray. Like,
Okay.
Heavenly Father, we thank you so much this morning. We thank you so much for the things you've given unto us. May you bless this lesson, enable us to understand, enable us to grasp something today before we leave this lesson. Guide our teachers. Amen.
Amen. Thank you so much, Simbuzi, for the prayer.
Welcome.
Okay. All right. Now, those of us who carried on the exam, I want us to quickly go through the work together. And the work that we did was combining actually 3 topics that we had so far worked on. And that was we had the binomial theorem, okay? The binomial theorem. Then we also had the part of the sequences and series. There was a number there. Sorry, that is the geometric progression, and then the arithmetic progression, which we had also looked at. And we had also started on working on with the differentiation. That is these are the 3 topics that we had focused on. And we had finished covering the first 2. We're done with the binomial theorem, as well as this part of the geometric progression and then the arithmetic progression. And we had gone on to look at the differentiation. That is what we had been covering for the last 2 weeks. That is what we had. So I want us to just do a brief of the revision of this, and then we shall be good to go as we come to the end of it all. Okay, so we look at question by question. Now, those of you who worked out, there were a bit of challenges some people were meeting. One, when you're working out, some of your work is incomplete, okay? Incomplete work. Now, also, people were leaving out certain steps, okay? Missing out steps. Now, some people, you would work out 1, 2, you leave out the third, the fourth step, then you put an answer. Now, for us, usually we don't look at that final answer. We are looking at how did you come to that given answer. So we mark so much that part of the steps. They are so important. So don't leave out any bit of the step. Work it out within and then carry on the presentation. Okay. So this is some of the steps, and I think with the submission, I think I had only two people who failed to submit in the work. I think somehow they had issues, so they submitted just the question paper, and the advice that they resubmit the work so that I can still look through as well. That is what I advise them to do. Okay. So moving on, here are the questions, and we are starting with question number 1. Now, this question, this is where we started on with the binomial theorem. Okay, it was under that part of the binomial theorem, and we had something to do with this. They're saying find a coefficient of x power 5 in the expansion of this. Now, when you have that kind of expansion, let's look at this. Please, if you have anything, you can always raise an hand, or you send me a text, and then we could carry on the discussion. So we have the expansion x squared minus 2 out of x power 3, and this is to the power of 15. Okay, and we are supposed to find the coefficient of x to the power of what? Power of 5. That is what we need to do. Now, to start with, we know that to find the nth term, there is a formula that we use. So for example, if you find the nth term, we have u r plus 1, meaning we are finding the nth term or the next term within our expansion. We use the formula n combination r, a n minus r, b power of r. Now, this formula here is key as far as finding the nth term is concerned. Okay, so this is the same formula that is going to help us to find the coefficient of this given term x power 5. Okay, now, so we do the substitution. Now, in our expansion here, some things that we should be knowing. Our n, okay, our n here is the power here 15. That is our n. Our a is this first term here, which is x what? Which is x squared. Okay. Then our b is this other one here. Now, some people are writing b as just 2 out of x squared. Sorry, x cubed. Not knowing that this one is a minor, this is a negative. So make sure that you carry it on. It has to move with the negative. Okay. So don't leave it out every time you write it. Then the r is not given. We don't have our r. Okay, we don't have our r. So what task do we have? We need to first find our r. Then after finding the r, we do the comparison. Then we can be able to come up with what? We can be able to come up with the coefficient. So we do the substitution here. So this will be equal to n, which is 15 combination r, which we do not know. A is x squared. Okay, our a is x squared, so we shall write x squared, and the power is n minus r. N is what? N is 15 minus the r, which we had to find out. Then times the b, we're saying the b is, okay. Someone saying something? Okay, please unmute. Okay, good. So this is what we have. So from here, we are substituting in for the b. So the b is negative. So make sure you take it as negative 2 out of x cubed. Okay? Out of x cubed. And the power here is to the power of r. Okay? Now, I remember we got a couple of methods when we were using the binomial theorem, and I gave you circumstances under which we use each of the formula. And remember, somewhere we talked about this power here is the one that dictates what we are supposed to be using. Okay, the power here dictates a lot what we need to use. And we said, like, we said when you have a fraction or when you have a negative, there is a, now, when you have a fraction or a negative, this one does not work, okay? Simply because you may not easily get a combination using the negative or using the fraction. So in most cases, there is another formula that we use, the one which is 1 plus what? 1 plus nx. This is the one that we'll use when you have a fraction or when you have a negative what? A negative power. Most cases we utilize this. But if we just have our power as a whole number, in most cases this is what is best suited for that. Okay. So moving on from that point, we just have to carry on now. That we just have to solve this. So what do we have in simplifying this? We shall have 15 combination r. When you open up the brackets here and multiply, we shall have x. This is 30 minus 2r. Okay, 30 minus 2r. That will be 30 minus 2r. Then when we bring this the other side, all right, so what we are saying, so from here, please mute Mr. King. Okay, so we are here. So we are opening up the brackets here, okay? Now, remember, you see this one here, we turn it into like a whole number. Now, remember when we're solving our differentiation, we said this one, you can put it as negative 2x, okay? X power negative 3. All this one is the power of what? Power of r. Okay? When you bring this one, when you bring the x up, it becomes a negative. Okay? So, okay. So we are here. So from here, we move on. So we shall have 15 combination r, x 30 minus 2r. Okay? Now we separate these two. Okay? We can have, this will be negative 2 to the power of r. Then this will be x negative 3r. Okay? This is what we've done. We've separated these two here. Okay, so that's there in the video. They are separate terms. Now, the next thing we have to do is to collect like terms now. We now collect our like terms. Look at this x here, power, and this one here. We bring them together. Okay? So this means that we shall have 15 combination r x. Okay? So this will be 30 minus 2r minus 3r. And then we shall maintain our negative 2r. Okay? We shall remain with our negative 2r. Okay, so here when you simplify this x, when we simplify our x here, we shall be having 15 combination r, then we have x30 minus 5r into negative 2r. That's what we have. Now, the other thing that we now need to do, remember this x to the power of this x here, 30 minus r, is compared to this c, x to the power of 5. Okay? We compare this one here that we have is compared to this, meaning this x power 5 is equal to the x30 minus r. What are we finding out? We are first finding our r, then from our r we come and find the coefficient. That's what we are doing. So we compare these ones here, okay? And when you do so, you'll be able to find your r. So therefore we shall now have our 30 minus 5r being equal to what? Being equal to 5. When you solve this, your r will be equal to 5. When you solve this, your r will be equal to 5. Okay, this will be your r. Because we've generated it from here. We compare it with the other x power 5, then we get our r as that. Now, after finding that, we now go back and do the substitution. We come back and do the substitution where we had 15 combination r, okay, x30 minus 5r into negative 2r. We now know our r. So you do the substitution. You put your r there. So here we shall have 15 combination r is 5, combination 5, x30 minus 5r, this will be x, I think it will be 5, power 5, okay? Because when you substitute here, this will be 30 minus 5 times 5, this will be 30 minus 25, which is 5, okay? Then we shall also have our negative 2 to the power of what? To the power of 5. Okay. So therefore, we've now clearly got, when you press into your calculator, 15 combination 5, you should be able to get a result there. When you get 15 combination 5, now, I got most students just putting 15 combination 5 and getting the final answer. Yeah? So 15 combination 5 will give us 3003. Then times this one here, times negative 2 power 5 x to the power 5. Okay? X to the power 5. So when you multiply through times that, you should be able to come up with your final result as minus 960.96 x to the power of what? X to the power of 5. Okay? X to the power of 5. Okay? So when you get this, it means now that our coefficient, please don't just stop here, then leave it like that. Conclude, therefore, the coefficient of x to the power of 5 is negative, okay, 96,096. That will be now your final coefficient that you will be having, because this is what we need, the value that is right there. Okay, so literally, please, some of you, I was crossing a few things because you were skipping a lot of steps. There were learners that were skipping steps. Yeah? Someone from just here, all of a sudden you see the final answer coming in. Please show your steps. Show your steps. Otherwise, you may miss out some of the marks. That's where some learners were missing out some marks from. So try to ensure that you put all your steps and include them. Okay, so this was your final answer here as far as that was concerned. Do I have any question here before we proceed to the next? Have a little time left. Someone with a question on this before we proceed? Okay. All right. So I saw some people who were doing this. Some people were just getting 15 combination 5 and finding our final answers 303. Yeah? You are missing out this. Okay, you could have, we don't know where the 5 came from and what, but this one made you miss out the mark on that. So try to ensure that you complete up your result. Okay. Okay. Bob has a question. Yes, Bob. Yes, Bob.
Good morning, teacher.
Morning.
Good morning, teacher.
Good morning.
I just wanted you to echo a bit how you brought in the x to power 5 in the equation, yet
Okay, I think I get it.
Yet everything there is still unknown.
Everything is unknown. Bob, can you re-echo your question? Bob? Okay, seems there's a bit of a network issue.
Yeah, I know.
Okay, so I think the issue was here. The point, I hope, maybe, I think that is where. Now the formula, get our formula where we got it from. We started from this point here, okay? This was our general formula that we got. Then from there, we did the substitution based on the expansion that has been given to us, okay? We carried on the bit of the substitution. Now, not everything is unknown here. We do not know R, but we know that this X here, because the X is is now the value that we are trying to compare to. Remember, it is we are looking for the coefficient of X power 5, okay? And remember, we only have, this is the only one that we have with this power. This is what we only have. So that's why we carried on a comparison with this alongside the x30 minus 2r. That's where the comparison started in from. Because we do not have any other, because this is what we are referring to as far as our working is concerned. So that's why at the end of it all, we had to compare it with D30, I think it is 5R, okay? And this is going to help us to generate our R at the end of it all. That's how we carried on the comparison at this moment, at this point. Okay, Hilary. Yes, Hilary.
Good morning, sir.
Morning.
But if they asked for, let me reverse the question and like find the coefficients of x power 4 and x power 5 in this. Can it be asked?
X power 4
and x power 5 in the
now
expression.
those will be done separately now. They can't be in the same. Now the same thing, we are going to do the comparison, okay? Meaning here, your x, we shall now use x to the power of what? We shall now use x to the power of 4. Remember, we've already got the 1x of the power of 5. Yes. We've got the 1 of the power of 5. Then the other side, we shall now compare with x to the power of what? Power of 4. we compare it with this other one here.
Okay,
This one.
thank you.
Okay, please. Okay, so literally that part of the x to the power of 5 is the one that is going to help us determine our r. And when we already have the r, then it is easier from that given point. Okay. Moving on. Working out the second question here. Find the first 3 terms of the expansion of the expansion. Hence, find the cube root of 2 to 5 decimal places by putting x equals to 0.001. Okay. Do I have someone who can try to work out together for us? Okay. Together, maybe someone can try to share with us. If you're there and you can try to work with that, help us. So we are finding the first 3 terms of 1 plus 24x to the power of what? Power of a third. Okay. Now, dear members, when we are working out, it is important that you first generate the formula. Okay. First generate the formula, the one that you're going to use. Then after generating the formula, find out what each of the terms is going to be represented to do the substitution. If you have A, you say now A is this, B is this, then C is the other one. Now we know that when we are to find this one here, remember, look at our power now. Our power is a third. So therefore, be sure we are not going to use now the other one of the combination. Okay, we shall not use the one of combination. So we shall use the one of 1 plus x to the power of n being equal to 1 plus nx plus n into n minus 1, okay, out of 2 factorial x squared. Now, remember that I've said the first 3 terms. This is term number 1, 2, 3, meaning you're supposed to stop here. Now, another thing is, when you, please ensure you add the plus and the continuation sign there. Some of you are just stopping there and then you are just working out, pausing at that. Please add on that, okay? Meaning it is continuous, it has not ended there, but the question just wants the first 3 terms. So try to add the plus and then you add the other dots to show that it's a continuous part of it. So we now find out what is our n. Our n is the power, okay? So our n is a third. Another term, what is our, another one is the a, the x. Okay, our x is 24x, that is our x. These are the things that we need to find out from here. Okay, now once you know that, then you do the substitution now. So when you do the substitution, we shall have 1 plus n, which is a third, times x, which is 24x, okay, plus n, which is a third, into a third minus 1, okay, over 2 factorial x squared, which is times 24x, 24, that squared. Dear members, our x, sometimes some people were just putting here, they were just putting x, not 24x. That's where another challenge was coming in from. So at the end of it all, you realize that when you're solving, you're not going to get a complete value. You're just going to work in terms of x, not in terms of what you have here. Okay? So you can only put x here, like for example here, if it is just 1 plus x, that means your x will remain as x. But if it is 2x, 3x, what, please take it as a whole. Okay? Then plus, the dots continue. Someone might ask him or herself that, what if I take on 4 of them? If you take 4, first 4 terms, you're going to mess up as well. Just take only the terms that have been told to you to take on. Okay? All right. So when you simplify this, another issue is simplifying this other thing here. So when we simplify, we shall have 1 plus 8x minus 128 out of 2x squared. When you open up this, 128x squared. So don't forget plus the dashes. Please, solving this one here, it is now a calculator issue. Remember, this is a calculator issue. There is no logic that is really required much here. It is just a calculator issue that we need to work out with. Okay? So from here, we shall be having 1 plus 8x. When you solve this, it will be minus 64x squared. Put the plus and then continue. That's what we'll be having. Okay. Now this will be now your expansion, the first 3 terms of the expansion. This will be, this solves the first part. Okay. This is where you stop. For the first part, you get these marks here. But key thing is putting the formula, okay, knowing the formula you're using, then carrying on the right substitution, and then the final answer here. Whatever you do here, make sure it brings up a final result here. We don't have anything much to do here. But what's more important, doing the right substitution and then finding the final answer here. So you realize that in a normal bit, you take like 3 marks there. Okay, or even 2 at times, substituting, or actually roughly 3 marks are the ones that you build on from that point there, are the ones that you'll be getting. Okay, now, the other thing is the hence, this part here. Hence find the cube root of 2 to 5 decimal places by putting x equals to 0.001. Okay. Now, what you're supposed to be doing is do the substitution here from this 1 plus 24x. This is the power of a third, meaning it is equal to 1 plus 8x minus 64x squared plus on and on. This is what it is like. So what are we supposed to be doing here? We are supposed to do the substitution. Okay. Let me try to reduce this. Okay. You're going to do the substitution here. So we said our x is equal to 0.001. Okay. 0.001. Hope that's what we have. 0.001. So put it here. Now, sometimes you can put, what is this 0.001 in fraction form? What is it like in fraction form? Let me ask who? Hillary. What is 0.001 in fraction form?
1 over 1,000.
1 over
1,000.
1 over 1,000.
Yes.
Okay. Now, when we put this, it a bit simplifies our work when you're doing the calculations throughout. That's why at times you do that. But if you don't, you're going to realize you're going to press the calculator a lot more times. So to avoid that, in most cases, we try to do that bit of the substitution. So here we are now going to have 1 plus 24 times 1 over 1,000. Okay. This is the power of what? Over a third, which will be equal to 1 plus, here we have 8 times 1 over 1,000, okay, minus 64 times 1 over 1,000. This is squared. That's what we have. we have this. So from that point there, you now try to punch into the calculator to get this one here. Punch in your calculator here, you get that. So this will be equal to, I think most of you are getting 1.0079, I think 36. Now, people were stopping here. This is equivalent to 1,024. I think it's out of 1,000. This is the power of what? Power of a third. Now, most learners, most of us were stopping here. Okay? Most of us were stopping here. And it means that your mark stops here. There are marks that you're going to miss out at this point. Now, I want you, when you're working out, you know, in math, you may be knowing the answer, but how to come to the answer. Remember, in the final thing, they want us to find the cube root of what? Of 2. Now, when you punch this into your calculator, can you be able to come to this? When you punch that into a calculator, I think when you punch this into a calculator, you get 1.25 something, around 1.25. This is what you will be getting. Now you see that this one here is far, far, far away from this one here. Okay. So therefore, we may not say that this one will be equivalent to the other one there. So what are we supposed to do in this case? Meaning that we are supposed to simplify. Why would you include the fourth one? You don't even deserve a mark when you include the fourth one. Like, definitely, that is, I think Joy was asking that. You don't deserve a mark when you add the fourth one, okay? So, therefore, what we need to do is try to simplify this one here until we are able to come up with that given result, okay? All right. All right. So we continue, we have a little time left. So from here, we now need to simplify this one here as far as possible so that we can be able to come to this. Now here in simplification, we can pull out 1 out of 10 into this one. Now what are we trying to, we are aiming at getting something like a root of 2. That's what we are aiming at. We are aiming at getting something like that. Sorry, the third root of the cube root of 2. We are aiming at this. That's what we are aiming at. So in all that you're writing this other side, make sure you have a 2 somewhere that is there. So here we can say, I can look for any value that I multiply by to get this value here, but it has 2. Okay? And I can get a cube root of that number. When you see 2 times 512, 2 times 512, I think you should be able to come to this. So pick up a number whereby you have to multiply it by 2. Then when you can also get the cube root of that other number that you have. Okay. So in so doing here, I'll be having 2. We shall be having 2 times 512, okay, to the power of what? Power of a third. So of course, this is equivalent to 1.007936. Okay, so so separating these two, I will have 1 out of 10 into, this is 2, this is the power of a third, then also 512 to the power of a third. Not squared. This is a power of a third. Okay. Now, 7936. So in so doing, when you get this one here, you realize that the cube root of 512 to the power of a third, I think you'll come up with 8. Okay. So meaning it will have 1 out of 10 times 8 into 2 to the power of a third, which will be equal to 1.007936. 36. That's what we'll be having. Okay, so what you do, you get it out. So meaning we'll end up with the 8 out of 10 into 2 to the power of a third, which is 1.007936. 36. Okay, and there, and then what we shall do, we now get the 8 this other side, the 8 out of 10 the other side. So you multiply it by the reciprocal. What is out of 8 times 8, 10 out of 8 times 10 out of 8. We are multiplying it by the reciprocal so that we eliminate this, so that we remain with only 2 to the power of 1, power of a third. That's why we are doing the reciprocal. So we shall have 2 to the power of a third is like the third root of 2, which will be equal to, okay, which will be equal to, when you multiply this, 1.0079 okay, so 1.00 times 10 out of this, when you multiply through, you should be able to get 1.25. But they say to 5 decimal places, so meaning 2599. I think these are 4, and then there is 2, which will be equal to this. But remember, you've gotten this one here based on the expansion that you've done. Okay, based on the expansion. I know when you punch into your calculator, you can get the result, but we are supposed to use this expansion here that we got by substituting 0.001, and then you carry on with that. Okay, so you realize that when you punch this into your calculator, when you punch it into your calculator, you should be able to come up with this one here as your final result. Okay? Now, the issue comes in manipulating this other part. That's where challenges come in. But you can always do a reverse kind of, you already know where you're heading, yeah? But you try to work out to make sure you get to that point. We knew that where we are heading is the third root of, this is our final destination. But we try to make sure you simplify it as far as possible, and it will involve taking some other terms the other side to be able to come up with your final result. So get to know your final destination, then you work backwards to make sure that you come to this final part that is there. Okay, Bob. Yes, Bob.
Teacher, to take you back a bit to the first number.
Hey, the first number.
Yeah.
In comparison to the second one? Yes, Bob.
Yeah, that one which has the coefficient of x to power 5. So someone asked that what if it was x to power 4? And I don't see how we would arrive to getting the coefficient of x to power 4. Yeah, so my question is, here, when I look at the substitution, when we substitute 30 minus 5, we got 25. And then when we divided it, we got our R as 5. Then when we substitute it into, the power of x, gave us x to power 5. So what if it was
what if it was?
What if it was x to power 4? How would you go about it?
Now, we were saying that still, if it is x to the power, meaning we want to find the coefficient of power of x to the power 4, right? That's what we are looking at. And here we now, when we reach at this point here, we do that at this point here. This is where we did the comparison from here, where we say that this is, we are assuming that this is where the x to the power 4 is here. So meaning it will be now x to the power 4 being equal to the x into 30 minus what? Minus 5r. Okay?
Yes.
Yes. So from here, you do now, we now say our 4 is equal to 30 minus 5r, and then you'll be able to come up with your r. Of course, the r may not be a directive value as we got it as 5, because that's how the question was set it and was targeting that. Because this was at what if it is, maybe if it is the same thing, but it is 5, it is 4. So meaning you'll be able to get your r here as well. So in so doing, you carry on with the comparison and then you get your final result. I think we answered it that way. Yes, Bob?
Teacher, I think you're not getting me very well. I think here we're 15 combination r x to power 30 minus 5 out of r, and then multiply by negative 2 to power r. So we get our r, and then when we substitute it, we actually get x to power 5. There.
That's why you're not, that's why I'm saying you are not going to expect it to be this, because the question is not set towards x to the power 4. But once a question is set towards this x to the power 4, what you're saying that here at the end of it all, you should be able to come to x to the power of 4. This is what you should be able to come up with. I think this is what you're talking about.
Yeah.
But in this same question, yes, this is what you're saying. Yeah? You should be able to come up with what? To x to the power of 4. That's what you should be able to come, that's what you should do, result to at the end of it all. So once you do your substitutions right, and it is the question that is tending towards that, that means you'll be able to come to this. But if you cannot come to this, if it is not 4, that means you're not going to carry on in a comparison. It can't, because whatever coefficient you're going to get is for this value here, is for x to the power of 5 or to the power of 4, if at all you got your r right.
Oh, teacher, I get you. So it depends on the question.
Definitely. It's not that you do everything, you carry on the same thing.
Okay, thank you, teacher.
Okay. I think that is it. All right. So I think we're done with that. We had another one here. Okay, differentiation. I think this was I think it was the most done and quickly worked out question, because that is what we're working with, where we said we had the 3x squared minus 6x plus 2 out of x squared, 2 out of x squared. Okay? 2 out of x squared. Now remember here we said we are differentiating each of the terms separately. Okay? Differentiate each of them separately. But the issue came here. Many people are failing to organize this one here. We said when you have 3x squared minus 6x. So here what you do, you put it 2, this is x squared, but this is negative 2. This is what you have. This is negative, it becomes negative. So in so doing, after that, we carry on now the differentiation, whereby we first bring the 2 this side. So this will be 2 times 3 x 2, we reduce the power by 1. Okay. Minus, here it is 1, so it will remain 6, maybe times 1x, 1 minus 1. Okay, then plus 2 times negative 2, then we have x negative 2 minus 1. That's how the differentiation is being done. So you realize we reduce the power by 1, and then the initial power that we have, multiply it by the whole figure. Then from there, we shall be having, this will be 6x, the power is 1, so you leave it as 1, minus, this is x, the power of 0, any number, the power of 0 is 1, so meaning we shall remain with 6, plus 2 times negative 2, this will be negative 4x, minus 2 minus 1, this is minus 3. Okay, so when you reorganize your work, we shall have 6x minus 6 minus 4x power of negative 3. Now, some people were also taking it back in its original form. 6x minus, actually this is minus 6 minus 4 out of x to the power of 3. It is fine. While I saw others were organizing it in this way, but literally the positive one starts, the positive value starts and then the other ones continue. So you would leave it in this form or you would put it in that form as well. It is fine, no problem. Either way. But the point is differentiate each of them separately. Okay? Okay? Differentiate each of them separately. Differentiate this one alone, then the other one alone. Maintain the signs. Don't change the signs. That is what you are supposed to do there. Now, the final one, the final question. This one was, I was trying to test to see if people were still reading the other things, but it seems people had forgotten most of these concepts. Please keep reading, keep reading. Don't leave out these concepts here. Keep carrying them on. Okay. When you go to another topic, it doesn't mean that you leave out the things that were there. Keep carrying them on and on. Okay, finally, we are saying the sum of the second and the third term. Second and the third term. So we can say this is U2 plus U3 is equal to 48. That's what we have. Of a GP. And the sum of the fifth, meaning U5 plus 6th, U6 is equal to what? 1 to 96. And we are told to find the common ratio R. The first terms are represented by A, and then the sum of 12 terms of the GP. Okay? That's all you need to do. That's the information you need to have. Okay? Now, we know that the sequence of geometric terms, we have AR squared, like that. AR cubed, AR power 4, okay? AR power 5, AR power 6, on and on. That's what you have. So you realize that the power on the ratios keep on increasing. That's what you need to have. So do the substitution here. So if you have U2 plus U3, this is the second, this is the third. So it means we shall be having AR plus AR squared being equal to what? 48. Then for this one here, we also have U5. So say this is 1, 2, 3, 4, 5. This is the fifth term. So it is AR power 4 plus AR power 5. Okay? Being equal to 1, 2, 9, 6. So these are the two equations we are going to work with. These ones here. Now generating these equations are marks for that. So once you've generated the two equations, you are now going to divide. Okay? 2 divide by 1. Okay? So we shall have AR power 4. Now we try to put them in a more simpler form, in a more simplified form. So where we can say, here we can say this is AR into brackets, okay? AR power, this is the AR power 3, okay? into brackets 1 minus r. 1 plus r, not minus, 1 plus r. Please, when you open up these brackets, you come to the same thing. We come to this. This is equal to 1 to 96. So we are dividing by still AR into, this is 1 minus, so 1 plus R. This is also divided by what? 40, divided by 48. Now someone was telling me, I got a challenge. How do you divide such a big thing? It's actually a very simple division instead. Right? So from here, what do you do? Hey, wait, hey, this is AR power 4, not 3. Someone is reminding us here. This one here. This is AR to the power of 4. I think when you open up these brackets, this AR power 4 times 1, it is AR power 4. AR power 4 times R, it comes to this. Thank you for that reminder. So from here, we just cross this one, we will cross out with this. Okay? This A crosses out with that A. The R once, the R reduces to 3. Okay? So this one also, we reduce it down, this comes to 20 what? 27. That's how you're doing the quick division. So you'll be remaining with R to the power of 3 being equal to 20 what? 27. So you get the third root of this. So what will be your R? Your R will be equal to what? Will be equal to 3. So the R is now the common ratio that you've got. So your common ratio here is what? Your common ratio here is 3, as you've seen it there. Now, having got your common ratio, okay, good. Having got your common ratio R, you now do the substitution, either in the first equation or the second equation, one of them. So let's substitute in the first equation where we had AR plus AR squared being equal to what? 48. We know we are now finding A. A is the first term. Okay? We are now getting our first term. So this will be A into 3 plus A into 3 squared being equal to 48. When you open this, it will be 12A being equal to 48, and your A will be equal to what? Will be equal to 4. So you've gotten your first term as what? Your first term as that. Now, dear members, once you get a wrong common ratio, be sure the rest of the things are going to be wrong. No matter how good the formula that you use is, the rest are going to be wrong. Once you get your R as something else. Okay? Then finally, they say the sum of the first 12 terms of the GP. So the sum, we know that the sum is A into R power n minus 1 out of R minus 1. Now you see that the sum is becoming now a walkover because you know your A as 4, your A is 4, your R is 3, and your n is the number of terms, which is what? Which is 12 that you're looking out for. So you do the substitution here. So it will be now S12, which is equal to A, which is 4 into 3 to the power of 12 minus 1 out of R, which is 3 minus what? 3 minus 1. And then your final result there will be 1,062,880. This will be your sum of the first 12 terms. Now, usually, please, the substitution is key. Okay, how you carry on your substitutions. Some of you get the right answers, but substitution becomes a problem. So try as much as you can to do the right substitution as you are here. I think that's what we had. That's what we had. Fine. That's what we had in all this. Unless there is a question as far as this last number is concerned. Any question as far as the last number is concerned? Any question, any question, any question, any question? Okay. Joy, is everything fine? Okay, Mr. Bernard, could you help us somewhere? Mr. Kakuro?
Yes.
They try to make you a host and I can't control here. Could you make me a co-host?
Yes, please.
Okay. All right. Okay, Msinguzi, as we close.
For me, I had a problem with actually number 2. Sorry for taking you back, but number 2 will be a challenge. Yes.
Number 2. I'm going to share the things here. I'm going to share the working so that we will see it as well. I don't know. I'm going to share the working. But the key thing was as far as the number 2, was it number 2? This is number 1, the coefficient, sorting this one here. I'm going to share this working here so that you can also try to review through as well. Okay, Joy, it was only 1 number, it is fine. I think we've now got the working, which is okay now. Okay, so members, I sent you those working for the numbers. Please try to go through them. The binomial through numbers. I'm going to send you some other ones. You check your Google Classroom. I'm going to put there some numbers as we close the entire thing. But check through and then you keep on working as well. Do I have any other question before we close? Or anyone with something to put across? Yes, these workings are on the YouTube channel. They are being recorded, so you after the lesson you get them as well. So all right, it's okay. We're going to get them on the YouTube channel as well. Okay. Thank you so much for being here and for the attendance. And I think this is our last lesson or something. And in case of anything, we'll keep you informed as well. But literally, I would think this will be our last meeting as far as this is concerned for now. But the other communications will be made to you as well. Mr. Bernard, in case of anything, I think we are done. Yes, Joy, your hand is up.
Sorry, sir, but I would like to ask something. So the lesson is going to continue. Sir.
Yes, please.
Are the lessons going to continue next week, or we are stopping on just revision?
I think as per the program, you're supposed to stop as for this week, as per the program. Maybe Mr. Bernard, Admin Bernard, we could do maybe add on something on that.
Yes, so formal communication will be made on Thursday. Don't miss that communication as they passed in your groups. Okay.